Hey there, Math Rockstars. We're going to finish up the interval notation notes by taking a look at a couple of examples. I'm going to describe the domain and the range of each of these functions using either set or interval notation, or maybe both. In each of these examples, you're given 3 out of the 4 rule of 4 parts. We have the model or the equation, the graph, and the data, the table of values. What we don't have is the verbal description. We're not going to know what the context is, but we are going to at least describe what the domain and the range are in all 4 of these functions. So let's start off with y equals x squared. The graph is a parabola, and then I've got a table of values over on the right. My graph, when I'm looking at it, I'm noticing that it looks like I've got all the x values. And what I mean by that is that on the right side, as I keep going, I can pick any number over here on the right side and plug it into my function x squared and get a y value. So if I take some really large number like 100, I can plug that in. I would just square it and get another even larger number. I could plug in 1,000,000. I could plug in 1,000,000,000. I can plug in any positive number I want, and it's going to work in my x squared function. And the same with any negative value of x. And I can get very negative. I could go to a negative 1,000,000.2 and square that, and I would get a value. So any number that I can think of, I could plug in pi. Any number that I want to use for my real numbers, I can choose to use in this set. So my domain, if I'm using interval notation, goes from negative infinity all the way up to positive infinity. And I'm remembering to use the parentheses, not the brackets, because infinity is not a number, so I can't include it. If I were going to do set notation for domain, I would write all x's such that x is an element of the real numbers. And that will describe every possible x in my domain. For the range, I'm now looking at y values. So on the graph, that means I'm noticing that my graph never goes below the x-axis. Everything is up here in the first or in the second quadrant. The lowest point on my graph is here at the origin at 0, 0. And if I look at the table of values, that confirms what I noticed in my graph. All of my y values are positive. They're all positive. In fact, the lowest number that I've got in my table of values is here at x equals 0. So that's my minimum. If I were going to describe that range using interval notation, I would say that the range, oh, come on here, black ink. There we go. The range, whoa, now I'm erasing everything here. Domain is negative infinity to positive infinity, or all x's such that x is an element of the real. So, okay, there we go. My range using interval notation goes from 0, but 0 is included, right? It's on my graph, all the way up to positive infinity. So there's my range using interval notation. And here's my range using set notation. It's all x's such that x is greater than or equal to 0. So 2 different ways to describe the domain and the range. First way using interval notation, second way using set notation. Let's look at the equation over here to the right, y equals the absolute value of x. And I'm going to let you know that this equation is actually wrong. And the reason I know it's wrong is if you look at the graph, you can see that the graph is slightly shifted to the left. And if I look at my table of values, really any one, but I just looked at the very first one, this says that if I have negative 3 and plug it in for x, so plug negative 3 in for x, I should be getting 2 as a result, but the absolute value of 3, negative 3, should be positive 3. So I know that this equation is not correct. We're going to adjust it a little bit. After you've worked through the transformation section of notes, you would be able to do this, I think, without any difficulty, and maybe you've already figured it out on your own. Good for you. We're going to add 1 to whatever x is, and then take the absolute value. Looks a little like an 11, but it's really x plus 1 inside absolute value bars. So let's just try that with our -3. So the absolute value of -3 plus 1. Absolute value of -3 plus 1, -2. And the absolute value of -2 is a +2. Yep, that's working. Let's try another one. Let's try this one here maybe. So when x is 1, I'm going to add 1 to that. Absolute value of 1 plus 1 is the absolute value of 2, which is 2. All right, so I think we fixed the equation all right. Now we can do what we're supposed to be doing, which is to describe the domain and the range. So these are going to look really similar to our first example. The domain, once again, is everything, right? I could take any number that I wanted to and plug it into the absolute value bars, add 1 to it, and then take the absolute value. Any number will work. I could use a really negative number. I could use fractions. I could use an irrational number. They're all going to work just fine. And when I look at the graph, I can see that it's continuing in both directions. And anywhere I wanted to pick an x value, I could look up here and find a y value on my graph. So my domain is still going to be -infinity to +infinity. My range, even though the graph has shifted over to the left a little bit, is still the same because my smallest value here is a 0, right? That's the lowest y value that shows up. So the lowest value, the minimum, is going to be a 0. And then it will keep going up in both directions. So as my x's get a lot smaller, my y values head off to infinity. As my x values get bigger, my y values also head off to +infinity. So my range is going to be brackets 0 all the way up to +infinity using parentheses. Y equals the square root of x. Now I'm looking at a graph where I only see the function in the first quadrant. I don't see any negative values of x being used. There's nothing over here in the second quadrant, nothing there. There's nothing below the x-axis, so nothing in the third or the fourth quadrants. Everything is right here in that first quadrant. Why would that be? Well, think about what would happen if you plugged in a negative value into the square root of x. So say I picked x equals -25. Somewhere out here, -25. And I wanted to know what the y value ought to be for that, so I could plot a point on the graph. Well, I would plug -25 in for the square root of x, right? So take out the x, plug in -25, and then I realized that I have an issue because there is no number that I could multiply by itself to give me -25. 5 times 5 is +25. -5 times -5, well, that's also a +25, so this does not exist. Anything over on the left-hand side of the graph is not going to show up in my function. And it's reflected again in the table of values, right at -1. If I plug that in for x, I get an error message on the calculator. The minimum value, the lowest value that I can use is a 0. So my domain is going to start off at 0, which I can use, right? The square root of 0 is just 0. And then I can use any number I want as long as it's positive. So it's going to go from 0 inclusive all the way up to +infinity. There is my domain. My range is never negative. My range is only up in that first quadrant. And if I look at my table of values here, it looks like I only have positive numbers or 0. So my range is exactly the same as my domain. Starts off at 0 and then continues on forever, up to +infinity. Last one, y equals a negative x cubed. So in this particular graph, when I look at the negative values for x, over here on this side, looks like all of my y values are positive. And when I look on the right side of the graph, where all my x's are positive, the graph shows up in the fourth quadrant underneath the x-axis. So all of my y values at that point look like they're going to be negative. And this is true in my table of values as well. Looks like my domain is all real numbers. So let's use set notation for this one. So it's the set of all x's such that x is an element of the reals. You can use any real number you want. That means I can pick any number I want and plug it into the negative of whatever that number is cubed. Any number will work at all. And then the range goes from positive infinity to negative infinity. So we don't write it in that direction. We write it this way. The smallest value first, but it's still it means the same thing, that my numbers that I'm going to get for the y values are going to range from very, very negative numbers up to very, very positive numbers. I probably better put that in set notation too, right? So the range is the set of all x's such that x is also an element of the reals. All right, in the next video, we'll take a look at end behavior.